All right, so I think this is recording. Let's take a look at problem number 30 of our review packet from Skill 3, Relations and Functions. Here they're giving me a function and asking me to determine the inverse. But this one is a little bit of a unique problem. Let's take a look at it in great detail. Um, we see here that they're giving us the domain, and normally when we have a quadratic function, the domain is all real numbers, but they have decided for whatever reason that the domain of this, the set of x's, the input for x to be greater than or equal to 3. They could have written it like this as well and just flat out said domain of f. That's what this implies, this inequality. All right. Now I know that quadratic functions, that the graph is a parabola. The parabola in this case, because the leading coefficient is positive, it opens upward. Now, it passes a vertical line test. I knew it's a function, but it fails the horizontal line test. So this function is not a one-to-one function. So I would not expect its inverse to be a function. If it fails the horizontal line test, it's not one-to-one, and only one-to-one functions have inverses that are also functions. But this isn't exactly what I have in this problem. What I have in this problem, we're going to look in more detail, and I'm going to show you that the x-coordinate of the vertex is 3. So on the left-hand side, I drew my parabola as a dashed line, because if I look at different points that are on this parabola, if this is the vertex 3 comma y, if I want values of x that are greater than or equal to 3, it's only points to the right of that, and this is the axis of symmetry. It's only points that are on the axis of symmetry or to the right of the axis of symmetry that have x coordinates that are greater than or equal to 3. On the left, none of these points have an x coordinate that is bigger than 3. So we throw out all those points. We've restricted our domain to be from 3 to positive infinity, and now it passes the horizontal line test, because the left half of this parabola is no longer a part of my graph. They've excluded it when they restricted the domain. So if I have a function, because it clearly passes the vertical line test, if I have a function that passes the horizontal line test, it's a one-to-one function. And one-to-one functions have inverses that are also functions. So when I go to find the expression for this inverse, I'm expecting it to be a function, because we've restricted the domain to make it so. All right, so let's look at this in a little more detail. Now, I told you that I had believed that the x-coordinate of the vertex was 3. How did I know that? Well, I could complete the square. If we write this just in terms of x and y's, if I wanted to square this, I would need a trinomial. I would have to take half of -6, which is -3, and square it. That's +9. So I can factor that trinomial. But I've changed the problem by just arbitrarily adding a 9 on the right-hand side. So I can balance the equation by adding 9 to the left-hand side, or just turn around and subtracting it from here, because 9 minus 9 cancels, and that's another way to balance this equation. I'm going to choose to do it that way, because watch, now I can factor this as x minus 3 quantity squared, and 2 minus 9 is a -7. So I have my quadratic function in vertex form, where I know the vertex, and we used to call it hk if you remember, the coordinates of the vertex. Well, the parent function is x squared. You've shifted it to the right because it was bizarre, but then you shifted it down, is 3 -7. Okay, so I've got my vertex is here, and I only have the right half of the parabola. we're throwing out the left half because the values of x are greater than or equal to 0. So since this passes the the horizontal line test, and I already knew it was a function, it passed the vertical and now it passes the horizontal, it's a one-to-one function. So I know the inverse is going to be a function. So let's write down the domain and range of this function. So I'm going to shrink this up a little bit, my ugly graph. And I am going to just write the coordinates of my vertex over here on my graph. 3, -7. I'm going to erase this because I'll need this room. Alright, and I know that they're telling me the domain is greater than or equal to 3, and I can see from the picture this is all of these points that are on the graph are above -7, so y is greater than or equal to -7 is the range. If we switch the domain and range, we switch x and y's. So to find the inverse, I switch x and y, and I even do it here in the inequalities. Y greater than or equal to 3, x greater than or equal to -7. So now I need to solve this equation for y. Let's add 7 to both sides. So I have y minus 3, that's squared. And if I add 7, x plus 7, and I'm not going to keep writing my restrictions. So those are coming along for the ride. I'll write them again once I really need them. So if I take the square root of each side, on the left-hand side, when you take the square root of a perfect square, you just get the base. And since I took the square root of a variable, I need to introduce plus or minus here and take the square root of this quantity, x plus 7. So to get y by itself, I add 3 to both sides of the equation. And if I leave it like this, I know that when I have a plus and minus symbol in my equation, I know that can't be a function because this really splits into two equations, and you'll have one x that produces two different y's. But remember that this restriction was coming along for the ride. I need this y to be greater than or equal to 3 and x to be greater than or equal to -7. So what we're adding and subtracting here with this radical, by the definition of a square root, a principal square root, this is a positive amount. So you have 3 and you're adding and subtracting a positive amount. So if I subtract, then those y values, if I have 3 minus a positive number, that result's going to be less than 3. So I can argue, because of this restriction, that I don't want to subtract. Those are going to create values of y that are not in the range. We only have to have addition here. So that definitely makes this a function, because with the plus and minus it fails to be a function. But here with the plus, think back of our transformations, we know that the square root of x is going to be transferred 7 units to the left and then 3 units up. So I also know from the graphs that we worked on the other day, well, I shrunk that graph. Hopefully I grouped it. Did I? No, I did not. Is it going to? Oh, it's going to allow me to do it. So if I expand this for a minute, and if I expand my x and y axis, now this is a rough sketch, so I don't know if it's really going to illustrate what I'm going to try to illustrate. The square root of x plus 7, I move 7 units to the left, and then the plus 3, I go 3 units up. So this point is -7, 3. Now notice, if we look over here, the x and y's have switched. 3 became a y coordinate, -7 became an x coordinate. And I know that this is going off like this. And if you were to graph this on graph paper, to where it looks a lot nicer than what I've sketched it, you would see that we have mirror images of each other, that we have symmetry with respect to this line y equals x, that this guy and this guy are mirror images of each other with respect to the line y equals x. That's always true about inverse functions. They'll be symmetric across the line y equals x. So my inverse, and let's use inverse notation, is the square root of x plus 7 plus 3, and our domain and range, well, we don't have to write x greater than or equal to negative 7. That's implied when you look at this square root. The domain has to be greater than or equal to negative 7. And the range really, even though I'm writing it down, I know that this is a positive amount, and I'm adding 3 to some positive amount. So I know from the equation that my domain and range satisfy the inequalities that I had brought along. See, up here, it's not obvious. Without that x greater than or equal to 3, the domain would have been all real numbers, and we would have had the left-hand side of this graph, of this parabola, and it would have failed to be a function, because then we would have had plus or minus here, which would have had this part, and you can see if it would have had the plus or minus, if it would have had the minus, it would have came down, and this would have failed the vertical line test and not be a function, because if we had this, it failed the horizontal, so we would know that its inverse is not a function. But by restricting the domain, we created a function that passes the horizontal line test, that is one-to-one, and therefore its inverse will be a function. Anyway, I hope that helps, and let's move on to, so here's my final answer, and let's move on to the next one. Talk to you later.